So today we are going to be talking about common logs. We've talked about a couple of different ways to solve log equations. We've used our log properties. Now we're going to get into common logs and what happens when none of those other things work. So that's what we're going to focus on today. Today's video is brought to you by Conalonzo Inc. As always, we're here to help you with your math. Our goals for this lesson are to be able to use our calculator to evaluate a common log. You're definitely going to need your calculator handy for this. This is not mental math here. And we're going to use common logs then to solve a log equation. This is yet another method to solve a log equation. And we're going to talk about how it works, when it works, and how you know when to do this. Common logs are logs that have a base of 10. We use that log button on our calculator. And when we're taking a log base 10 or a common log, the base is not written. So for example, if I wanted to find the log of 27, I would punch in my calculator, I'd hit the log button, 27, and then I'd hit equals. And I'm going to get a decimal, okay? These are going to be longer decimals. I'm going to get 1.43136, et cetera, et cetera, et cetera. Go ahead and punch that in your calculator. Make sure you get the same number. Now I have put log 27 is approximately equal to, remember those little squiggly equal signs, is approximately equal to 1.43. For the most part, we're going to round to 2 decimal places and make sure that you're trying to round correctly. Okay, so again, I hope you punch this in your calculator, use that log button, hit log 27, make sure that you get the 1.43, etc. One of the things that we do with common logs is we do something called a change of base. Any log, whether it's base 10 or not, any log can be written as a common log by changing the base. We're going to do that by dividing the log of the answer by the log of the base. So log base 3 of 25, we cannot evaluate this with a calculator. There's no way to put in a log base 3. The only kind of log we can evaluate with a calculator is a common log. So we're going to rewrite this as the log of 25 over the log of 3. This we can evaluate. Okay, so we can put in our calculator log 25, close your parentheses, divided by log 3, and we get 2.93. It's actually 2.929947, etc. We're going to round that to 2.93. So log 3 of 25 is basically asking 3 to what power equals that. And we can evaluate that with a calculator, okay? If you think about it, 2.93 is close to 3, right? And we know 3 to the third power is 27. Therefore, 3 to the 2.93, et cetera, power is 25. That's what we're finding here. But we have no way to do that unless we use common logs and using a change of base in order to evaluate with our calculator. We're going to evaluate a couple different things here. So let's try log 7 of 41. To do that on a calculator, which remember, evaluate means get your calculator, we're going to take log 41 divided by log 7. And then I'm just going to punch that into my calculator. Please remember to close your parentheses or your calculator doesn't know what to do with this. And we get 1.908, which rounds to 1.91. Log 4 of 53, whoops, we would take log of 53 divided by log of 4. Again, just put that in your calculator. And you get an answer of approximately 2.86. We're always taking the log of the answer or the bigger number divided by the log of the base. Okay, that's very important that you do that in the correct order. So we want to take log of 17 divided by log of 2. And we get 4.09. Last one here, log 42. Look, there's no base because this is already in base 10 or in common log form. So we're just going to punch in log 42 on our calculator and get an answer of 1.62. So now we know how to evaluate any log with a calculator using a change of base. This is going to allow us to solve log equations. So here's some steps for you. First step, isolate the exponent. Undo any operations to get the base and the exponent alone. So for example, let's say you had something like 3 times 5 to the x. You would want to divide by 3 in order to get that 5 to the x alone. Second step, take the log of both sides. The exponent then becomes the multiplier. We know this from our log properties. And then we can divide by the log of the base. This gets that variable by itself, and then we can punch it in our calculator and find the approximate value of x. Now we're going to show a little bit of work for this. A lot of this is going to be done on our calculator. So please make sure you're not clearing your screen between steps. Okay, put it all into your calculator and then perform the next function on the answer of the previous one. That way you don't get any round off error. So our first step is to isolate the base and the variable. That's already done here. We have 3 to the x. We don't have anything else. There's no coefficient. There's nothing that we're doing. Step 1 is already taken care of. Step 2 is to take the log of both sides. We're going to take the log of 3 to the x and the log of 11. Now what we're going to do is this x becomes the multiplier. We have x times log 3 is equal to log 11. Our next step is to divide both sides by log 3. It cancels here. Just like when you have 3x equals 11 and you divide by 3, you're doing the same thing except you're dividing by log 3. And you can see that what happened is the log of our answer is over the log of our base. And that's going to give us x. So we're going to punch into our calculator log 11 divided by log 3, and we're going to get an approximate answer of 2.18. And that is our solution. That means that 3 to the power of 2.18 is about 11. If you punch it in, it's actually 10.967, etc. That's why we use the approximately equal to, because rounding means it's not exact. So we're isolating the base and variable, which was already done in this problem. We're taking the log of both sides, and we're dividing. And lastly, we evaluate with our calculator. Let's try another one. Here we're going to take the log of both sides. And I kind of like to combine two steps just to make it a little more efficient. So I'm going to just write that x in front. Now I'm going to divide both sides by log 5. Because that's what cancels it away from the x. Now I'm going to punch into my calculator, log 62 divided by log 5, and I'm going to get an answer of 2.5. Okay, so x is approximately equal to 2.56 here. Let's try one that's a little harder maybe, but we're still going to follow the same steps, okay? Now, the y minus 1 is the whole exponent. So our first step is to isolate the base and the exponent. That is done here, even though the exponent is a little funky. That has been done. So we're going to take the log of both sides. And when we do that, remember that the exponent becomes the multiplier. Then we're going to divide by the log of 5, which was the base. And we end up with y minus 1 equals whatever these two things divided is. Okay? So let's punch that into our calculator. Log 8 divided by log 5 is 1.2920, etc. Now, do not clear your calculator. Leave that number on the screen because to solve, we need to add 1. So with the 1.29 on the screen plus 1, I now have 2.29, 029, etc., blah, blah, blah. That is my solution, okay? It doesn't make as big a deal here because we're just adding, but when we start getting into some of the multiplying, dividing, other things, keep your answers on your screen so that you don't get round off error, okay? Let's try another one. This one is 11 to the y plus 4 equals 27. We're going to start by taking the log of both sides and turning that exponent into the multiplier. Then we're going to divide both sides by log 11. And we get y plus 4 is equal to whatever log 27 divided by log 11 is. Let's figure that out. 1.3744, etc. And now we're going to subtract 4. So on my calculator, because I still have that decimal in there, I'm going to minus 4, and I get negative 2.63. Y is approximately equal to negative 2.63, and that is my answer. This one is a little different because we've got that 7x. So instead of adding or subtracting something at the end, we're actually going to be dividing by 7. But first, we're going to divide by log 2 because that is what is going to simplify. So log 5 divided by log 2 gives me 2.3219, etc. Now I'm going to divide that by 7. Again, I'm keeping this on my calculator. And x is approximately equal to 0.33. Okay, please make sure that you're not rounding. You don't want to cause any error, round off error, and your answer will be significantly enough different from the solution that it will not be. So here we have 4 to the 2x is equal to 14. We're going to do the same thing where we're taking the log of both sides. Whoops. And we are going to make this 2x a multiplier. So we have 2x times log 4 is equal to log 14. I hope you're starting to get the hang of this by now. I'm following that whole process of rewriting, dividing the logs, and then simplifying by whatever the equation has, whether it's a coefficient or it's x plus 4 or whatever. So I'm taking log 14 divided by log 4, and I'm getting 1.903, etc., which I'm going to then divide by 2. And I get a final answer of 0.95, approximately. And that is my final solution. So I hope you're understanding how to change a base, how to get the exponent and base alone, how to solve with common logs, and most importantly, can you put it into your calculator correctly? I hope the answer to that is yes. If it's not, go back, watch the video again, and do some practice. Make sure that you understand how to put this into your calculator so you can solve appropriately. As always, we're here to help. Please let us help you. Let us know if there's anything that you need. You have all of these resources available to you. You have this video. You can come check out our math lab after school. You can ask us questions in class. We are more than happy to help you with whatever you need. Just let us know. Hope you're feeling good about solving log equations. Do your practice and let us know if you have any questions. Take care.